Thanks for coming to this late afternoon session. Can you hear me well over there? Yeah. My name is Massimo Re Ferre. I'm part of the team at Amazon Web Services that build Amazon Q Developer and Kiro. And what I would like to do in these next 50 minutes in this session is to share some of the experience that I've observed by both building the tool and observing the other engineers building the tool, as well as users that are consuming these tools, right? So my session, the scope of this session, I'm not going to talk about products or anything, but the scope of this session is from the lenses of someone that has this kind of background, right? And what I've been observing by, as I said, watching people building and consuming these products. Before I start and I get into the meat of the presentation, I wanted to kind of set the stage a little bit, more like the system prompt for the session, so to speak, right? And I wanted to say a couple of things. Where are we as an industry in 2025? The first thing that I usually say when I talk to the users typically is if you hear someone saying that they have figured it out, they're probably lying, right? And I know that it's pretty ridiculous to hear this from someone that is building these tools, but this is the reality, right? And one of the reasons why this is the reality is because the pace of innovation is unprecedented, right? I also usually joke about this fact that 1 year in generative AI equals more or less 3 dog years and 29 EC2 years, right? The pace at which we are innovating in this space as an industry, right? I'm talking in general, is incredibly fast. I've never seen anything like this in my 30 plus years in the industry. The second thing that I want to say before we get into kind of the content that I wanted to share with you is that this notion of, and of course I'm exaggerating a little bit, but you need to forget almost everything that you know and learn about computers in the past. Now, as I said, I'm a little bit exaggerating, right? Because what you have learned and what you will learn in computer science is going to be extremely useful. But there are many things in generative AI, especially in this particular space where we're talking about generative AI coding assistant tool. There are a few things that are very different, right? So this notion of non-determinism versus determinism, right? If you have been in the industry for for a long time, where you're used to things work the way that they should be working, right? And if they do not work the way that they should be working, it's a bug, right? Whereas in this space, it's very different the way that you approach this kind of technology. The second reset that you need to think about when you approach this world is that this notion of backward compatibility versus evolving behaviors, right? And this goes a little bit beyond like these coding assistants, like Kiro, Cursor, Amazon Q. This goes a little bit beyond these things, and it gets into like how agents operate, right? We're coming from a world, especially with the background that we have at Amazon, where the rule number one, beyond security, of course, but the rule number one is you do not break the experience of the user, right? I remember working on other type of services. I used to work in the container services organization. And the moment that you introduce a new feature into a new service, regardless of how awesome that feature is going to be and how useful that feature is going to be for a particular customer, you're not going to break the default experience that they're having that day before you launch that feature, right? So this notion of evolving a generative AI agent and not having to stick to backward compatibility is something that is kind of mind-blowing for some of the people. The other thing that is interesting to me that we have been experiencing by doing this stuff is this notion of doing tests and evaluations, right? And this goes back a little bit to backward compatibility and evolving the system. In the traditional, in traditional computer science, I mean, there are tests that you run to make sure that you do not have regression, and then, you can ship your software, right? With your new stuff, new versions, and things like that. In generative AI, there is this notion of evaluations, right? And these evaluations are different from, canonical tests, right? These evaluations typically involve a ground truth where you know the answer and you test these systems to see if they provide you with the right or wrong answer, right? And bleeding into artificial intelligence, this kind of work if what you're testing and evaluating are pictures of dogs and cats, right? It's pretty easy because the ground truth says, yeah, this picture is a dog. Let's evaluate the system to see if it spits that it's a dog. And if it says that it's a cat, it's wrong, right? So there was a regression, for example. In the world that we live today, it's going to be incredibly different to do these evaluations, right? So think about spec-driven development, and I'll talk briefly about spec-driven development throughout the presentation. But the moment that you have a workflow that generates like literally thousands of lines of code, how do you evaluate this system, right? There are maybe like more than a dozen ways to run those thousands line of code that are awesome, right? That would be great. So there isn't really a ground truth that you can evaluate against, right? So incredibly difficult. However, these are problems that needs to be solved, right, in some shape or form, because the people that are working on this product and are iterating on this product cannot go all the way to the user to get this kind of feedback and back. They need to iterate by having a short loop of these feedbacks, right? So these are problems that exist today, but needs to be in some way resolved. The other thing that I've observed is this notion of fixing bugs versus steering behaviors, right? And this relates a little bit to all these other points where we are used generally to think about a system as either working or not working, right? And if it doesn't work, you open a bug, right? So in this world, there are, of course, bugs in the systems, right? Where it's obvious that there is a problem with a certain mechanism that you need to fix. But more often than not, what you will see with these systems is that you are observing a bad pattern, right? So you're not opening a bug to fix a particular problem. You're not opening a bug to say, well, the LLM responded in a way that it's not exactly the way that I would wish it responded with, right? So you kind of try to basically get a pattern of these behaviors, and then you start steering the system and the agent toward the way that it is supposed to be working, right? So it's very complex to deal with these systems with the mindset of, that we're coming with. So I wanted to talk a little bit about these things during the presentation. These are short kind of peels of topics that I wanted to touch upon. One is, of course, how did you get here, right? How did we get to where we are today? And I do remember I've been doing this work or the job for about 3 years. I probably started this job when I first saw ChatGPT back in, December 2022. And I remember observing that, ChatGPT and thinking, I mean, this thing is great, right? I can do things with these kind of tools, or that tool at that time, because there were not many of them. And the whole purpose of that was kind of, the knowledge, right? If you think about that, the whole value of ChatGPT back in the days was kind of the knowledge that you would be able to extract from the system, right? Then we moved to a phase that was kind of, what I refer to generic knowledge versus specific facts, right? Or specific knowledge, where we went through this phase of maybe we can augment what the LLM knows in a way that is very specific, for example, for my organization, right? I can upload documents into the LLM so that the LLM can also know about myself, right, and my organization. I think that this phase faded out a little bit, right? I was joking with someone yesterday about the fact that the theme of these events seems to be like friends do not let friends run, rag any these days. So this kind of approach faded out a little bit. Where we are today as an industry is this model here, right? You have heard many times talking about this agentic behavior, right? And to me, this is way more than a model, right? So if you think about these, there are a couple of things here, or two or three things that are, very, very important. The first one is if you look inside those boxes, we moved away from this notion of knowledge or knowledge plus into this notion of reasoning, right? The big advantage of these models as of late is the fact that they can reason about stuff, right? It's not that they know about stuff. Of course, they still know about a bunch of things, too many things, maybe. But the real value is in that reasoning thing. And what really changed kind of the landscape was this notion of tools or MCP servers in context, right? So these are the very, very key things that makes like the agent that we know today so powerful to be able to do the things that they do today. Let's dive deep a little bit into this notion of context. Why context is important? Because for everything in life, there is a simple rule that is garbage in, garbage out, right? That is kind of the rule that you need to take in to keep in mind for something that works versus something that doesn't work, right? If you feed the model with the right information, it will reason in a way that will spit out something that is useful. If you do not feed the model with something that is, relevant, probably what you're getting is something that is not as good. So let's talk a little bit about this context thing. And we often talk about tools in the context of augmenting the knowledge of the model by connecting to outside systems, right, or to backend systems, right? The typical example, canonical example that everybody has heard so far is, I can connect to weather.com and get the weather in London, right? Which I found a stupid example because you can hard code the answer of that and you say, it always rains, but that's a joke. But the notion of tools, at least the way that they have been conceived at the very beginning, is you can use tools, which is basically code that you run somewhere to connect to external systems to augment this knowledge and this context, right? But if you think about what happened in the last, maybe 6 months, you have probably heard all of these things, right? And of course, we don't have time to go through all of them, but you have heard about things like, of course, prompts, because I think prompts are part of the context, but specialized agents, sub-agents, dog-related MCPs, memory, steering or ruling files, personal knowledge, organizational knowledge, right? There is a huge amount of projects out there that are trying to address how you manage all of this information and how you funnel them into the context to provide the context to the model. The one thing that is interesting about this, if you read the text in the middle that comes from a document that Anthropic posted a few days ago, is this good context engineering means finding the smallest possible set of high signal tokens that maximize the likelihood of some desired outcome. This is very key, right? Because many people think that, I need like the 1 billion or 1 million kind of tokens type of context, right? But the real key here is to make sure that off of all the things that you have inside your system, you extract the stuff that is useful for that moment, for that transaction that the LLM is doing, so that it doesn't pollute the entire context and it doesn't do anything crazy, right? I just wanted to point out one here, sub-agents, right? You have heard probably many sessions here, the notion of sub-agents or multiple agents orchestrated. Typically, this is done for like business reasons, right? Maybe you have, as I said, specialized agents that do things that another agent doesn't do. But it's incredibly interesting how a lot of these techniques of spawning a sub-agent are nowadays used to not pollute the context. So imagine that you're running something inside your agent and you want to do something else that this agent could be doing very well, but you do not want to pollute the context because maybe that additional task will require, polluting the context by, a large amount of token. So what you want to do is to span out like that process, do all of that ephemeral agent, that ephemeral process, do all the stuff that you need to do and get the result and kill the agent. Right? So using these agents as a way to not grow the context too much is another interesting way that these techniques are being utilized. This also leads me into this other topic, which is kind of interesting, maybe not super passionate, right? Which is kind of the pricing of these things. And the reason why I put it here, because there is a very direct correlation between the context and the amount of token that you're using to how these things are run and how much they cost to run these things, right? And so there is this, right now, there is this maybe somewhat interesting dichotomy in the industry right now where the users are pointing to the vendors and the vendors are pointing to the users saying, you're too expensive, right? And this is because there are misalignment in terms of the way that these, and here I'm talking particularly about these coding agents, right? So as I said, Cursor, Copilot, Kiro, Amazon Q, all these kind of agents, because the way that the industry has decided to kind of, standardize on how these agents are brought to market is by this notion of a subscription, right? And this misaligns with the need for a vendor that provides those tools to try to track the actual cost of these agents, right? Which are incredibly expensive to run, right? And one of the reasons why they're expensive to run is because if the context blows up, there is a direct proportional formula to how the cost there grows exponentially. I left a couple of links here of some Substack and Reddit thread, which are very interesting to read if you're interested. I have a QR code at the end for getting the slide if you're interested. But they are interesting and hilarious in some respect, where they get into kind of the reason why this is happening, right? So there is this real clash that no one has found a good solution for, in my opinion, where the developers that are using this tool are like, it costs too much to use this, and the generative AI tool provider that are, it costs too much to run this thing, right? There was a very interesting talk earlier today about someone that was showing a reel of a developer that would go home at 1 p.m. and they were like, where are you going? Well, I ran out of tokens, so I'm going home, right? And the other thing that is interesting, that is less of a joke, is that it's very interesting to observe now stand-up meetings, for example, where people are talking about what they have done, not in the currency of time, but in the currency of tokens, right? Usually you would say, well, I spent half a day trying to figure out how to build this feature. I didn't go nowhere. Nowadays, it's very common to hear people saying, well, I spent like, 100 tokens trying to solve this problem and it didn't work out, so I'll get back to it, right? So very, very interesting dynamics that are happening. The other topic that I wanted to talk about, as you can see, I mean, they are kind of disconnected in a way, because the way that I typically run this presentation is I dump what I think is kind of interesting for the last period of time, and I subdivide them into these different peels. And one of these topics is this notion of specs, but I want to talk about this idea of English as a programming language, right? So if you think about the evolution of coding, I'm not going to school you on this because, I mean, I think that you can school me on this stuff. But if you think about how you started, with editors, IDE, autocomplete, inline suggestions, right? I kind of started, this job when we were pretty much there, right? As I said before, I kind of started when ChatGPT was launched. And as a matter of fact, I divide the word in before ChatGPT and after ChatGPT, right? Which is kind of a good way for me to think about this. And after ChatGPT, you started to get inside your IDE things like, ChatQA, right? So this was not at that point agentic in the sense that you were still kind of leveraging the knowledge of the model, right? The model was not doing stuff on your behalf. So in that case, you had like a separate window where you can chat with the model and maybe copy and paste the result into that. And then we moved into this agentic chat or vibe coding, right? I'm not going to kind of explain what vibe coding is because you probably heard many times during this conference. And where we are today is like in that space where we're at this spec-driven development, right? So I see this more as an evolution of how you do things. And notice that because what I said at the beginning, that this space is running like at speed of light, I wanted to put a question mark over there, right? Because who knows what's coming next, right? But I want to talk a little bit about this notion of spec-driven development. If you think about, I mean, this is a slide that I was showing maybe 18 months ago, probably more, right? And I had this idea of how do I communicate what a good framework for using these tools is, right? And my idea was to present a framework that was similar to this, right? So you have two lines that basically represents the knowledge that you have on a particular topic, right? So say that you are a Java developer, you would be on the right-hand side, high level of knowledge. If you are a Java developer and you're playing with Rust, you would be on this side of things, right? Low level of knowledge for the topic at hand. And the assistant or the LLM backing the generative AI assistant would have kind of a similar way of representing this, right? In terms of its knowledge about that specific topic. So imagine that you are here, right? Basically, everything that you do on the right-hand side, you're basically out of control, right? Whereas everything that you do on the left-hand side, you are in control because you know what you're doing, right? So one of the things is that on the right-hand side, there is very high return. On the left-hand side, there is very low return because it's very tempting to get the LLM to do things that you don't know about, right? Because that is a very high return, more than doing stuff on the very left-hand side that you can probably do, easier on your own, for example. So I came out with this kind of notion of a boost zone where if you are close to ask things that you know about, but they're kind of complex to do manually, you're in that boost zone, right? You can also be in that learning zone, right? So you go a little bit farther down in uncharted territory, right? But still in a place where you are kind of confident that you can understand what it is doing and you're actually learning, by doing that. So using this assistant as kind of educational tool also. Where you do not want to be is in that dangerous zone, right? Where you are completely out of control for very complex stuff that you're doing in Rust and you don't know anything about, right? So you do not want to be there, just like you do not want to be there because maybe it's going to take you more time to write a prompt that do the things on your own, right? So you want to be in that kind of zone over there. There is a QR code for the slide later on if you want them. And then, of course, a few months later, maybe even a few weeks later, Andrei Karpathy, that I'm pretty sure everybody knows, came out with this idea of vibe coding, right? Go all the way to the left, right? Danger zone, YOLO mode, like forget about kind of, how it's writing the software, which works extremely well, right? It does work extremely well and it has its place, I think, right? Just to give you an example, we have some PMs in the team at Amazon at large that instead of writing a document about what the new feature needs to be, they're starting to use these techniques like vibe coding because they're not like developers, right? So they're not like writing good code, quote to quote, right? But they are vibe coding kind of a prototype that they can then pass to the engineering team saying, we need to build this feature. Go and build it for real, right? This is a prototype, go build it for real. So there is a very interesting space for this notion of vibe coding, YOLO, and the way that vibe coding works. Because if you think about how vibe coding works, is pretty much like you start with the prompt, and you need to get to an artifact, right? To the thing that you're building, whether it's a prototype, a new feature, or something. But the way that this works, and remember what I said at the beginning, like garbage in, garbage out. You have to give to the model information about how to build a feature, a tool, or something, right, that you want to build, right? The way that this works in vibe coding from a visual perspective is that you keep prompting and you keep steering the model inside your guardrails. I'm not talking about guardrails in the sense of, former guardrails. I'm talking about guardrails in terms of you're steering the model to build the thing that you need, right? Oh, there are error messages, fix them. Oh, I don't like where this is positioned on the web interface, just reposition it, right? And there are also points where the LLM just take a U-turn and goes, somewhere else, and you have to go back and say, no, steer towards where I need to go, right? This is pretty much a visual representation of vibe coding. Spec-driven development. The way that I talk about spec-driven development is that you start from a very similar prompt, right? Imagine a prompt that is, I want to build a web interface or a web UI on top of this small application that doesn't have a user interface. It only provides APIs, for example, right? So you start from that little prompt, right? And then what happens is that you build specifications to build that thing, right? So the key thing here is that then you refine those specifications. I'll get into more details about what these specifications are. But the whole idea is that instead of just giving a prompt at a time at the LLM, you kind of build this notion of structure of what you want to build or what you want the LLM to build on your behalf, right? So you iterate on these specifications, and then eventually you say, just run, right? Apply this specification and build the feature, right? Which is pretty much the output that you were getting before, but in a very different way, in a more structured way. if you think about these two very different way of doing things, the way that I think about that is that in vibe coding is pretty much like doing ClickOps to deploy an application on AWS or on any infrastructure, right? Whatever, right? I say AWS because I use AWS, right? But the idea is that vibe coding is very akin to this notion of, let me try in the console to deploy this application doing like 100 or 150 clicks to do that. Whereas spec-driven development is more this notion of building a CloudFormation template or a Terraform template or CDK, whatever you use to define your infrastructure and actually run that to build or to deploy the application. The other example that I've seen, or the other parallel that I've seen other people using, is that, which I think is even more interesting in my opinion, is that this notion that vibe coding is just like a long Slack conversation about how to do something, right? Incredibly ephemeral, right? Whereas spec-driven development is just like a doc or a PRD that says, okay, we need to build these things, where everyone kind of contribute to that document, and that document is the source of truth for what you are going to build, okay? This is more of a practical example of what this means inside Kiro. And by the way, by show of hands, how many of you have heard about Kiro? A few people, okay, good. So Kiro is generative AI agentic IDE that we shipped a few months ago that has this particular characteristic of having spec-driven development built in, right? I'm not going to show you, everything, but on the left-hand side, basically on the left-hand side, you see all the mechanism that we use to bring in the context that I was alluding before, right? Steering documents, MCP servers, hooks is something that I'm not going to talk about. And one of the things is this notion of specs, right? So when you are in Kiro, but specs is not specific to Kiro. Kiro implements its own workflow to build specs, but there are many other also open source projects to do this. You get to select whether you want to do vibe coding or spec-driven development, right? So that is the chat interface where you select, I want to do things like YOLO mode, traditional mode that I described, or I want to use spec-driven development, right? If you select spec-driven development, this is what happens. You start with the prompt, maybe the same prompt that I was alluding to before. Build me a web interface that does XYZ on top of this application that only has APIs, for example, right? The first thing that Kiro does is it creates this requirements.md file. The requirements.md file is basically the PRD, right? And from that single prompt, right, it will infer all the things that you need. Of course, as I said before, garbage in, garbage out, right? So if you prompt a generic thing like what I just said, it's going to be imagining what your requirements are, right? And this requirements doc has, all the requirements, and for each requirement, the acceptance criteria. One of the ways that we have seen some users using this is in collaboration with the product management team, with the business. They would take their own inputs and they would give, instead of a prompt of one line, they would give that as an input to generate a requirements.md that is way more, specific to what they need to build, right? Garbage in, garbage out, okay? Good info in, good info out. You can iterate on this requirements.md, right? You can edit it, you can prompt to change stuff. Once you are okay with it, what happens is that it moves to the design.md. The design.md is where you specify all of the things that it needs to do from a technology stack perspective, right? Use this framework, use this language, use this architecture, use Redis for caching, use blah 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 blah, right? And the good thing is that this process is integrated with all the steering files and the rules that you have configured inside Kiro, right? So now you have the business view and the technology view, the architectural view, and the last step is that it creates tasks to implement this. Now you cannot see them, but basically those are the tasks, the individual tasks that you can actually start executing that points back to the requirements. You won't see this from over there, but if you see the first section, it says start task number 1, and in green it says this closes requirements 1.1, 2.1, 2.2, blah 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 blah. So it maps back to the requirements, right? And this is where you actually run this and you get your artifact as an output, right? Of course, you need to iterate on all of these until you say, okay, I'm good, and I'm going to deploy these. Now, a little bit more philosophical, right? The way that I'm trying to think about this is that imagine this notion of a source of truth, right? And this notion of development assistance, right? That these tools provide. On the other dimension, you have time, right? So yesterday, today, tomorrow, future. Notice that I qualify future as probably after I have retired, right? Just very down the road, right? Unfortunately, it's probably taking me another 10, 15 years, I'm not sure. But imagine where we started, right? Where the source of truth is, of course, the code, right? that is what you are checking into GitHub, right? It's not like the prompt or anything, right? And yesterday you had this notion of inline suggestions, right? Or autocomplete on steroids, as I used to call it. Today we are in this place where, of course, the source of code is still, the source of truth is still kind of the code, right? And then you have all these tools, including inline suggestion, but vibe coding and spec-driven development. What we are already seeing happening is that users are kind of, not confused, but they're starting to question, okay, what are these specs, right, that I have built to actually create the feature that I've been building, right? Are they part of the code, right? Should I check them into the GitHub repo because they go along with the code? And maybe there is a mechanism to retrofit them. If I change the code, it will retrofit kind of the specs that generated in the first place that code that I have changed then, right? So we are in this phase right now where we are debating, is this intent part of my source of truth, or is it something that is kind of, separate, ephemeral, so to speak, right? It's not hard to imagine a future, again, qualified as many years down the road, where your intent becomes kind of the source of truth, right? There are lots of people right now that are talking about, English as a programming language in the context of that becomes your source of truth, right? And basically code could become like a downstream artifact, right? Like today, a downstream artifact may be a build that you do of your Java program or whatever that you may be treating as an ephemeral thing because the source of truth is kind of the code in GitHub. We can imagine a future down the road where the intent itself in English is becoming that source of truth. This is Mark Broker is a distinguished engineer at Amazon that just tweeted a few months ago this thing, right? I wrote a Monte Carlo simulator in Python. It took 300 seconds to run. I asked QCLI to translate it to Rust, compile and run. It took 48 seconds, including translation and everything. Is Claude 4 the best Python compiler, right? You can imagine a future where you just say what you want to do and you let the LLM or the assistant that you're using to actually compile that into code, right? Again, I'm talking about a future that is not today and not next week, right? But at the pace that this industry is moving, I wouldn't be surprised if this is going to come earlier than later. I wanted to talk a little bit also about where I personally see these agents going in the next few, I'd like to say years, but probably month is the better way to describe this. If you think about the trends that we have seen so far, is that these tools are really kind of personal tools, right? Basically, they augment what you know, right? They augment your productivity. They augment kind of your knowledge. They augment, the things that you do from a personal perspective. And I think that this is a market that is, or a domain that is, somewhat proven, right? Definitely not commoditized. But if I was to ask you how many of you are using a generative AI coding assistant, maybe most of you would say that you're using one, right? I think that where we are going is that we're moving to a world where, in addition to these personal tools, we are going to have this notion of team tools, right? So instead of the agent being kind of bound to your own environment, to your own persona, being kind of a tool that augment yourself, I think that we're down the path where we're seeing these tools being more and more used by teams as a whole. And I think that there are many, players in this space that have already started playing with this notion. I think that Devin is one of those where they have started to kind of foster this idea of agents that are running in the background and they're augmenting the tools and these sort of things. But I think that this is a nascent domain, right? In terms of what users are actually using today. The slightly more technological view of these, not super deep dive, but the slightly more technological view of these is that, these are the personal assistant that you see today, right? They are typically bound to the person that is using them. They're typically bound inside the IDE, and they're typically bound to the repository that you're using to do something specific, right? Very, very specific to that. What I'm alluding to is kind of a world where these assistants are detached from the developer, right? They actually act as a potential team member, right? Think about like a bot on steroid of some sort, right? Where they have compute execution environments that they can use. So no longer your laptop, but your compute execution environment somewhere, right? They have organizational knowledge, right? So they're not bound to your knowledge. They're not bound to the knowledge of the single repository. They have org level knowledge of how things get done in your particular organization. And they're also kind of ambient, so to speak, right? They are in the places where you are today and you can collaborate with them, right? GitHub, GitLab, Jira, all these places where that you probably use today, right? So there is a very profound difference between these tools, right? So the tools on the left-hand side are more synchronous in the foreground, right? So they're client tools, so to speak, right? You use them interactively. They actually, provide you with an output as you use them, and you use them synchronously, basically. The others are more asynchronous, running in the background. You assign tasks to them. They will come back, right, at some point with the work that they have done, right? Pretty much like a team member, if you think about that. They're goal-oriented, as I put on the slide. And the other interesting thing is that they have this long feedback loop, which require high trust, right? So remember everything that we said, that you need to be in a particular zone, you need to review the code and everything. Of course, this notion requires that you do not check in into these assistants every 5 minutes, right? To understand where they are. Of course, there is a balance between how much they can do alone versus how much you want to check in with them. But the whole thing is that these tools are going to a place where you can let them do things. You can let them do more things that they can do today in this particular environment over here. The last few minutes, I wanted to touch about these, which is obviously an interesting, especially given what I said in the last few slides, right? Is this Skynet, right? Are they coming for us, right? And this is the question that everybody has, right? And honestly, I don't have a good answer to this, right? So I wanted to put together like a few maybe disconnected, thoughts to let you think about this, right? I think that the very first thing is, that I've seen people is that they approach this tool with different mindsets, right? I'm not sure if you know SWE bench, but this is kind of a benchmark that tests like how good these assistants are, right? Basically, you give them 1,000 GitHub repository with issues, and you see how many of them are being able to solve, right, on their own, okay? These are pretty old numbers, but it doesn't matter, right? Let's say that the success rate of these tools is 20%, right? So I'm giving you 1,000 GitHub issues to solve, and you're able to solve 20% of them, right? So there are two approaches, right? Two mental models that I've seen people using when they see that number, right? The first one is, it's wrong 80% of the times, right? The other mental model is, I can take all Fridays off from now to retirement, right? So you see how the mental model is important on how kind of you approach these tools, right? They could be friends, they could be foe, but it is also how you approach them. I also like this tweet from this person that said, I want AI to do my laundry and dishes so that I can do the hard and the writing, not the opposite, right? So this from an Amazon perspective, this is exactly what removing the undifferentiated heavy lifting has always meant to me, right? So you want to remove all the toys that doesn't give value to your organization or to you as an individual in order to be able to do the stuff that provide the biggest value in the end, okay? The other thing that I found interesting is, what if this is just a different abstraction level, right? So let's take, I'm not sure how familiar you are with the AWS technology, but I'm talking about AWS simply because I'm more familiar with these kind of technologies. And if you think about the infrastructure as code progress over time or progression over time, at Amazon, AWS, we have this thing called CloudFormation templates, right? These are JSON or YAML files that you basically describe, what you want, how you want your applications to be deployed, and it will just deploy that inside your AWS account. A few years ago, we announced a different level of abstraction on top of CloudFormation called CDK, Cloud Development Kit, or something like that. And basically, the idea is that instead of using JSON YAML, you will use a real programming language to actually define your infrastructure, right? You can use, Python, TypeScript, whatever, to actually describe your infrastructure. What if these tools are just yet another way to abstract this, right? Imagine creating a spec in English that says, this is how my application is going to be deployed, right? And the reason why I put arrows that goes both into CloudFormation and CDK is that then you choose, where you want to compile that abstraction into, right? You can compile it into CDK, and then CDK will compile it into CloudFormation, or you can create directly CloudFormation, right? But maybe this is another way to look at these things, right? It's just simply an abstraction that you're going to use and leverage that removes the toil of having to do things that do not provide real value. I also like the way that, I'm not sure if you have heard about this story of the bicycle of the mind from Steve Jobs. Basically, the idea is that he saw a study where someone was measuring the most efficient animal on Earth, right, to move from point A to point B. And basically, it turned out that the most efficient animal on Earth to move from point A to point B was the condor. And the human being was like down the list, like 50, 100, I don't remember, right? Because we're not efficient to walk from point A to point B, or at least not as efficient as the condor or many other animals. But then he read another paper where he said, if you give a bicycle to that human being, it blows the condor away. The man with the bicycle becomes the most efficient animal on Earth, right? And so he was using these to describe like the computer that he was kind of, introducing into the market to be kind of the bicycle for the mind, right? And so one other way to look at these things is, what if these generative AI assistants are the bicycle for the developer, right? That makes them more productive in the end. And the last slide that I wanted to show you is this, like the role of the developer will maybe change, not disappear, right? So if you step back a lot, and if you think about what happened in the industry in the past, you no longer do this, right? You do that. The people that were working at tolls, now there are engineers that are building like this Wi-Fi system to go through the highway without having to stop and do things, right? So I think that the idea here is that your job may change, but that doesn't mean that the economy will need less people, right? I think that there was also a talk about the Jevons paradox and all these things, right? So definitely my message to you is, brace yourself for a lot of changes in this industry, but if you are attached to the right technologies, to the right movements, I think that you will be fine. Thank you.